Hello viewers, I welcome you onto our lesson. My name is Tulani Hlachwayo. If you haven't clicked subscription button, please go below there and press subscribe button. Thank you for watching. We are dealing with past examination paper, that is 2008, paper 2. Right, we are going to look at question number 1B, but we'll look at item number 1. Remember, because we're dealing with a right-angled triangle. So, what does it say? If you read there the information on B, it's going to sum up everything into this diagram, the first diagram there. Then it tells you on item number 1, when when angle ATP is 90 degrees, angle ATP is 90 degrees. As you can see, a small box there. It says then you are needed to calculate TPA. You are needed to calculate this angle there. Right, so we are going to use trigonometric ratios. Because this is a right angle triangle and we are given two sides, we are required to find an angle. So opposite our angle is the opposite side. And then our hypotenuse is this side. And then that side, that's where we find our adjacent. We label the side so that we don't get confused. All right, so what we have there, what we are given hypotenuse. The hypotenuse is equals to 23. And we are given the adjacent. Adjacent side is equals to 15. So, which trig ratio are we going to use? Remember our SOHCAHTOA. Remember our SOHCAHTOA. So we have got hypotenuse and adjacent. This one sign is opposite hypotenuse, cos is adjacent. Yeah. So we are going to use what? Cos. Because it will be cos theta is equals to adjacent over hypotenuse. Adjacent is 15 over hypotenuse, which is 23. Right, so theta is equals to arc cos. Theta is equals to arc cos 15 over 23. Then we punch in our calculator. Then we get 49,3 degrees. So now that's item number 1. So it's TPA is equals to 49,3 degrees. Right, this is our answer. So, but right, let me dive into another thing there. Already we know our answer. Let's write it on the side. It's what? It's 49,3. Let's have it there. Now I want to give you another method. All right, let's look at another method. How can we deal with it in another way? Right, so we have got two sides. We have got two sides. Yeah, we know that one is opposite there, yes. And this one is hypotenuse. And the other one is adjacent. But now, if we have got two sides, let's try to look at the missing side. Let's try to look, let's say it's X, our missing side. So because it's a right angle triangle, we are going to use Pythagoras theorem. Remember the longest side hypotenuse, which is 23 squared, is equals to x squared, that side, plus 15 squared. So because we want to find the value of x, let's make x squared the subject of the formula. So which is x squared is equals to 23 squared minus 15 squared. So x squared is equals to, let's find it on our calculator, is equals to 529 minus 225, which is equals to 304. Right, the square root, this is x squared. So x is equals to the square root of 304, which is equals to 17,435,596. So that is the opposite side of our angle. This opposite is equals to 17.4. So now let's try to use these two sides. The opposite one, okay, the opposite one, which is 17,4, and the hypotenuse, and let's try to ignore this one. We try to find the angle again using these two. Let's see if we're gonna find the same angle that we got in the beginning. So right, because now we have got hypotenuse, we are going to use it, is equals to 23. But now we have got this one, the op, which is 17. So our opposite is 17, opposite 17,4. Right, so now given those ones where we have got hypotenuse and opposite, so we are going to use sine theta is equals to opposite over hypotenuse, that is 17,435 over 23. So theta is equals to arc sine of 17,4 over 23. Right, so when we go to our calculator, arc sine of, so we get 49,29, which is actually 49,3. So we still get the same answer like the one that we got in the beginning. So thank you very much for watching.